Good morning everyone. In the previous sessions we had discussed about the definition of a matrix, order, algebra of matrices, and in the last session we did solve few problems based on algebra of matrices, mainly on scalar multiplication and matrix multiplication. So in today's session we are going to start off with the new topic in the chapter of matrices, that is transpose of a matrix. The first definition in today's session would be transpose of a matrix. Let A be a matrix of order m cross n. The matrix obtained from A by interchanging rows and columns is known as transpose of a matrix and is denoted by A dash or A transpose. Let A be a matrix of order m cross n. The transpose of the matrix A is obtained by interchanging rows and columns, and the transpose of a matrix is denoted by A dash or A transpose. If A is a matrix of order m cross n, then A dash will be a matrix of order n cross m, because the rows are changed into columns and vice versa. Say for example, if A is a matrix of order containing the elements 2, 3, 4, 1, 2, 3. What is the order of this matrix A? How many rows does it contain? 2 rows. How many columns does it contain? 3 columns. How do you obtain transpose of a matrix? Rows are interchanged into columns, and which is denoted by A dash or A transpose. That is A dash, that is the transpose of the matrix A is written as the first row becomes the first column. You are interchanging rows and columns. 2, 3, 4 is in the first row. This becomes the column and is written as 2, 3, 4. The second row becomes the second column, that is 1, 2 and 3. What is the order of this matrix? How many rows does it contain? 3 rows. How many columns does it contain? 2 columns. That is m cross n order of the matrix A will become n cross m. This is about the transpose of a matrix. Moving on to the next topic, properties of transpose of a matrix. The first property of transpose of a matrix is A transpose, the whole transpose is nothing but A. When you transpose the transposed matrix, you will be getting back the original matrix. Second property, K into A whole dash can be written as K into A transpose. What is K? As I said in the previous session, it is a scalar constant. So taking out the constant, we can write K the whole dash is equal to K into A dash. The third property of transpose of a matrix, A plus B whole dash can be written as A dash plus B dash. The sum of any two matrices, when you transpose it on a whole, we will be getting the transposed of sum of two matrices. That is A plus B whole dash can be written as A dash plus B dash. And the last property of transpose of a matrix, that is AB whole dash is equal to B dash into A dash. AB is in terms of multiplication. When you transpose the product of these two, you will be getting the resultant answer as B dash A dash. So on a whole, the first property of transpose of a matrix is A dash the whole dash is nothing but A. K A whole dash can be written as K into A dash, where K is a non-zero scalar constant. The third property, A plus B whole dash is equal to A dash plus B dash, and the last one, AB the whole dash is equal to B dash into A dash. This is all about properties of transpose of a matrix. The first definition, transpose of a matrix. The second definition, properties of transpose of a matrix. And now we shall discuss about two more definitions which is related to transpose of a matrix, that is symmetric matrices and skew symmetric matrices. What is a symmetric matrix? if A is a square matrix, if A is a square matrix such that A dash is equal to A, then we say A is a symmetric matrices. If A is a square matrix such that A dash is equal to A, what is A dash? It's nothing but transpose of a matrix. Then we say A is a symmetric matrices. A is a square matrix such that if A dash is equal to A, then A is called symmetric matrices. A is called symmetric matrices. What is skew symmetric matrices? If A is a square matrix such that A dash is equal to minus A, then A is called skew symmetric matrices. A is called skew symmetric matrices. If A is a square matrix such that A dash is equal to minus A, that is negative of a matrix, then A is called skew symmetric matrices. Based on the definition of transpose of a matrix, symmetric and skew symmetric matrices, we shall be solving two theorems which is important from examination point of view. The first theorem, for any square matrix A with real number entries, A plus A dash is symmetric matrices and A minus A dash is a skew symmetric matrices. Proof. We will consider one matrix. Let B is equal to A plus A dash. We will consider one matrix B which is equal to A plus A dash. Taking transpose on both the sides or transposing on both the sides, taking transpose on both the sides, we get B dash is equal to A plus A dash the whole transpose. That is nothing but B dash is equal to, according to the definition of properties of transpose of a matrix, A plus B the whole dash can be written as what? A dash plus B dash. Similarly, we can write this as A dash plus A dash the whole transpose, that is transposing each term. Once again, by the definition of transpose of a matrix, what is A dash the whole dash equal to? A. Therefore, what is B dash is equal to? A dash plus A. But what is this A dash plus A? That is nothing but B. Hence, we can write B dash is equal to B. This satisfies the definition of symmetric matrices. Moving on to the second half of the same theorem. Now, we will consider, let C equal to A minus A dash. What is the next step? We are supposed to transpose on both these sides, that is LHS and RHS. When you transpose, what does C become? C dash. C becomes C dash and A minus A dash whole dash. According to the definition of transpose of a matrix, this is C dash. Transposing each term, what do we get? A dash minus A dash the whole dash, which is equal to C dash remains as it is, A dash minus, what is A dash the whole dash? By the properties of transpose of a matrix, which is nothing but A. But what is C given here? C equal to A minus A dash. But what did we arrive? C dash which is equal to A dash minus A. That is C dash is equal to, suppose I take a negative sign outside. What does it become? Plus A dash becomes minus A dash and minus A becomes plus A. Can I write this as A minus A dash plus A is same as A minus A dash. So this can be written as C dash is equal to minus of A minus A dash. What is A minus A dash now? By the definition, by our assumption, which is nothing but C. Therefore, what is C dash is equal to minus C. This satisfies the definition of skew symmetric matrices. Once again, I will explain. for any square matrix A with real number entries, A plus A dash is a symmetric matrices and A minus A dash is a skew symmetric matrices. Before we pass on to the proof of the theorem, let me summarize the properties of transpose of a matrix. What is A plus B whole dash? A dash plus B dash. What is A dash the whole dash, which is nothing but A. So, starting off with the proof, we will consider B equal to A plus A dash. When we transpose on both the side, what does B become? B dash. And what does RHS become? A plus A dash the whole dash. By the properties of transpose of a matrix, we are supposed to apply the transpose for each term. That is, B dash remains the same. A dash plus A dash the whole dash. A dash remains as it is. What is A dash the whole dash? As explained, nothing but A. So, what does A dash plus A complete term equal to? Nothing but B. Therefore, we can write B dash is equal to B. This satisfies the definition of symmetric matrices. Moving on to the second half of the theorem. Consider C to be A minus A dash. When you transpose on both the sides, C becomes C dash and this is A minus A dash the whole dash. So, transposing each term, A dash minus A dash the whole dash. A dash the whole dash can be written as A. So, we arrive at C dash is equal to A dash minus A. C dash remains as it is. When you take out a negative sign outside, plus A dash becomes minus A dash and minus A will become plus C. This can be written as what? A minus A dash. But what is A minus A dash? We have considered to be C. So, we can write this as C dash is equal to minus C, which satisfy the definition of skew symmetric matrices. Moving on to the second theorem, for any square matrix, we can express as a sum of symmetric and skew symmetric matrices. Any square matrix can be expressed as a sum of symmetric and skew symmetric matrices. Proof. Let A be a square matrix. Let A be a square matrix. Then we can write A is equal to A plus A dash plus half into A minus A dash, or A plus A dash by 2 plus A minus A dash by 2. From theorem number 1, we know that A plus A dash is symmetric and A minus A dash is skew symmetric. From theorem number 1, A plus A dash is a symmetric matrices. And A minus A dash is skew symmetric matrices. We know that by the definition of properties of transpose of a matrix, since for any matrix A, we have, by the definition of properties of matrices, what is K the whole dash, which can be written as K into A dash. Hence, it follows that A plus A dash by 2 is a symmetric matrices and A minus A dash by 2 is a skew symmetric matrices. A plus A dash by 2 is a symmetric matrices and A minus A dash by 2 is a skew symmetric matrices. Once again I will explain. Any square matrix can be expressed as a sum of symmetric and skew symmetric matrices. We will consider one matrix, any matrix you can consider. Here I have considered the matrix A. So, let A be a square matrix. Then we can write A as what? A plus A dash by 2 plus A minus A dash by 2. From theorem number 1, what is A plus A dash? Symmetric matrices. And what is A minus A dash? Skew symmetric matrices. So we can write from theorem number 1, A plus A dash is symmetric and A minus A dash is skew symmetric. Since for any matrix A, that is by the properties of transpose of a matrix, what is K? The whole dash, which can be written as K into A dash, and therefore it follows that A plus A dash by 2 is a symmetric matrices and A minus A dash by 2 is a skew symmetric matrices. Now we shall solve some problems based on transpose of the matrix. The first problem, find the transpose of the following. What is matrix A given? 5, half and 1. What is the order of this matrix? How many rows does it contain? 3 rows. How many columns does it contain? 1 column. How do you find the transpose? By interchanging rows into columns. How do we denote the transpose of a matrix? A dash or A transpose. Therefore, what is A transpose? Rows are changed into columns. This is a column. It will be changed into rows and can be written as 5, 1 by 2 and 1. How many rows does it contain? 1 row. How many column does it contain? 3 column. First column, second column, and this is the third column. So 3 cross 1. Order of the matrix A was 3 cross 1. After transposing, it becomes 1 cross 3. Moving on to the second problem. What is the order of matrix C? 2 cross 2. How do we denote the transpose of a matrix? C dash or C transpose. That is, C dash is equal to, interchange rows into columns. 1 minus 1 is an element in the matrix C which belongs to first row. That will be changed into columns and it can be written as 1 minus 1. Similarly, 2, 3 are the elements which belongs to the second row. Interchanged into columns, it will be 2 and 3. What is the order of the transposed matrix here? It is again 2 cross 2. Moving on to the third problem. The matrix D contains an elements 1, 4, 7, 8, 9 and 2. How many rows do we have in the matrix D? 2 rows. How many columns do we have? 3 columns. How do we denote the transpose of a matrix? That is nothing but D dash. Rows are changed into columns. The first row, that is 1, 4, 7 becomes the first column, which can be written as 1, 4, 7. Similarly, 8, 9, 2 horizontal becomes vertical, which can be written as 8, 9, 2. How many rows does this matrix, the transposed matrix, contain? 3 rows. And how many columns does it contain? 2 columns. So, order was 2 cross 3. After transposing, it is 3 cross 2. Moving on to the fourth problem. If A is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1 and matrix B equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. We are supposed to verify A plus B whole dash is equal to A dash plus B dash. That is, LHS is equal to RHS. We will consider LHS now. Consider LHS. What is LHS given? A plus B whole dash. Now, first, we are supposed to add these two matrices and then take the transpose the resultant sum of these two matrices. So, what is A plus B? What is the order of the first matrix? 3 cross 3. What is the order of the second matrix? It is again 3 cross 3. Order of both the matrices are same. Then their corresponding elements can be added, which satisfies the definition of addition of matrices. Which is the corresponding element of minus 1? It is minus 4. Minus 1, minus 4, minus 5. Minus 5. Similarly, 2 plus 1 will sum up to 3. 3 minus 5. 3 minus 5 will be minus 2. Next, 5 plus 1 will be 6. 7 plus 2, which is equal to 9. and 9 plus 0 once again, which is equal to 9 itself. 9 plus 0 will be equal to 9. Minus 2 plus 1, that is minus 2 plus 1 will be minus 1. 1 plus 3, 4, and 1 plus 1 will be again 2. This is A plus B. How do you transpose A plus B? By interchanging rows and into columns. Therefore, what is A plus B whole dash now? Rows are interchanged into columns. Can be written as minus 5, 3, minus 2, 6, 9, 9, minus 1, 4, 2, which is of order 3 cross 3. This is all about the LHS of the given matrix. Now, we will consider RHS. We got A plus B matrices answer, but we are supposed to find what A plus B whole dash. So, now we shall write what is the answer of A plus B whole dash. That is, you will interchange rows into columns. You are transposing A plus B matrices. Minus 5, 3, minus 2, 6, 9, 9, minus 1, 4 and 2. This is A plus B whole dash. This is about LHS. Moving on to the RHS part now. That is RHS. What are we supposed to prove? A dash plus B dash is equal to A plus B whole dash. We already arrived at the answer A plus B whole dash. Now we solve A dash plus B dash. What is A dash matrices? What is A? Minus 1, 2, 3. So what will be A dash? Rows are interchanged into columns, which can be written as minus 1, 2, 3, 5, 7, 9, minus 2, 1 and 1. What is B dash? Minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. This is all about A dash and it is B dash. Now we are going to add A dash plus B dash. So what is A dash plus B dash now? Order of both the matrices are same. Corresponding elements can be added. Minus 1 minus 4 will be minus 5. 5 plus 1, 6, minus 2 plus 1, minus 1. Similarly, 2 plus 1, 3, 7 plus 2, 9, 1 plus 3, 4. 3 minus 5, minus 2, 9 plus 0 is 9, 1 plus 1 will be 2. Call this as equation number 2 and call this as equation number 1. We can see equation 1 is equal to equation 2. Hence, we can write A plus B whole dash is equal to A dash plus B dash. Moving on to the next problem we have. If A dash is equal to 3, 4, minus 1, 2, 0, 1 and B equal to minus 1, 2, 1, 1, 2, 3, verify A minus B whole dash is equal to A dash minus B dash. We will consider LHS. We are going to prove the answer for LHS and call that as equation number 1. Now, consider LHS. Consider LHS. What is LHS? We are supposed to find A minus B whole dash. Before we find A minus B whole dash, we shall find A minus B. What is A minus B? What is A dash? 3, 4, minus 1, 2, 0 and 1. Therefore, what will be matrix A now? Rows are interchanged into columns. 3, minus 1, 0, 4, 2 and 1. This is matrix A. What is matrix B? Minus 1, 2, 1, 1, 2 and 3. In the given question, it is A dash. So, we are going to convert it into matrix A. So, what is A minus B? What is the order of the first matrix? 2 cross 3. What is the order of the second matrix? It is once again 2 cross 3. So, order of both the matrices are same. Therefore, corresponding elements can be subtracted and it can be written as 3 minus of minus 1 will be 4. 3, you are going to subtract with minus, minus of minus becomes plus. So, 3 minus of minus 1 will be 4. Similarly, minus 1 minus 2 will be minus 3, 0 minus 1 minus 1, 4 minus 1, 3, 2 minus 2, 0, 1 minus 3 will be minus 2. This is A minus B. But we are supposed to find what? A minus B whole dash. So, transpose the given matrix 4 minus 3 minus 1. The first row becomes the first column and it can be written as 4 minus 3 minus 1. 3, 0 minus 2 is the second row. When we transpose, it becomes the column and hence it can be written as 3, 0 minus 2. This is all about LHS. Now, we shall find RHS. This is LHS. Now, consider RHS. What is RHS? A dash minus B dash. What is A dash given in the question? 3, 4, minus 1, 2, 0, 1. B dash. This is matrix B given in the question. For us to find B dash, we are supposed to transpose the given matrix. So, what will be B dash? Minus 1, 2, 1, 1, 2 and 3. So, to find what? A dash minus B dash. A dash minus B dash. Call this as equation number 1. That is the resultant answer of the LHS. Now, what is A dash minus B dash? Order of this matrix 3 cross 2. 3 rows and 2 columns. Order of the second matrix, it is once again 3 cross 2. Orders are same. Corresponding elements can be subtracted. 3 minus of minus 1 will be 4. 3 minus of minus 1 will be 4. 4 minus 1, 3. Minus 1 minus 2, minus 3. 2 minus 2, 0. 0 minus 1, minus 1. 1 minus 3 will be minus 2. Call this as equation number 2. Hence, from equation 1 and equation 2, we can say that A minus B whole dash is equal to A dash minus B dash. Moving on to the next problem. If matrix A contains an elements minus 2, 3, 1, 2 and matrix B contains an element minus 1, 0, 1, 2, we are supposed to find A plus 2B whole dash. Before we find the transposed matrix, we will first find the answer of A plus 2B. What is A? Minus 2, 3, 1, 2 plus 2 times the matrix B. You are multiplying matrix B with 2. That is nothing but scalar multiplication. What is matrix B? Minus 1, 0, 1 and 2. So, this can be written as minus 2, 3, 1, 2. This can be written as minus 2, 3, 1, 2 plus scalar multiplication. You are going to multiply every corresponding element with a non-zero scalar 2. 2 into minus 1, minus 2. 2 zeros are 0, 2 ones are 2, 2 twos are 4. So, what will be the resultant answer? Order of the first matrix 2 cross 2, order of the second matrix 2 cross 2, orders are same, corresponding elements can be added and it can be written as minus 2, minus 4, 3 plus 0, 3, 1 plus 2, 3, 2 plus 4, 6. This is the answer of A plus 2B. Next, we are supposed to find what? The transpose of A plus 2B. So, what is the transpose of A plus 2B? What is A plus 2B whole dash equal to? Rows are interchanged into columns, that is minus 4, 3, 3 and 6, which is of order 2 cross 2. Similarly, moving on to the next problem. If A is equal to cos alpha sin alpha minus sin alpha cos alpha, we are going to prove that A dash into A is equal to I. That is, this is A matrix. We are supposed to find A dash into A. What is A dash? Consider A dash into A. Consider A dash into A. What is A dash? This is cos alpha sin alpha minus sin alpha cos alpha. This is A dash. First row becomes the first column, the second row becomes the second column. What is matrix A? Cos alpha sin alpha minus sin alpha and this is cos alpha. matrix multiplication row wise. Cos alpha into cos alpha, it is cos square alpha, minus into minus, plus minus sin alpha into minus sin alpha will be plus sin square alpha. We are starting off with the first row, finishing with all the corresponding columns. Similarly, cos alpha into sin alpha minus sin alpha into cos alpha, matrix multiplication. We finished with the first row, ended up with all the columns in the second matrix. Similarly, second row with the first column, this is sin alpha into cos alpha, sin alpha into cos alpha minus cos alpha into sin alpha. Sin into sin alpha will sum up to sin square alpha plus cos square alpha. By Pythagoras identity or by trigonometric identity, sin square alpha plus cos square alpha is equal to 1, plus cos alpha sin alpha minus sin alpha cos alpha gets cancelled, becomes 0. Similarly, plus sin alpha cos alpha minus cos alpha sin alpha gets cancelled, becomes 0. What is sin square alpha plus cos square alpha according to the trigonometric identities? It is nothing but 1. This is called what matrix? This is nothing but identity matrix of order 2 cross 2. How do we denote the identity matrix or unit matrix? Always denoted by capital I. Therefore, I is equal to 1, 0, 0, 1, which is of order 2 cross 2. Moving on to the next problem, we have for the matrices A and B, verify AB the whole transpose is equal to B transpose A transpose, where A equal to 1, minus 4, 3 and B equal to minus 1, 2 and 1. We are supposed to prove LHS is equal to RHS. So, AB is given in terms of matrix multiplication. So, we will first consider AB. Consider LHS, that is matrix AB. Matrix AB. What is matrix A given in the question? 1, minus 4, 3. What is matrix B given in the question? Matrix B, minus 1, 2 and 1. What is the order of the first matrix? A contains how many rows? 3 rows. How many columns? 1 column. What does matrix B? How many rows does it contain? 1 row. How many columns does it contain? 3 columns. What is the order of matrix multiplication as explained in the previous session? The row of the first matrix is always equal to column of the second matrix. So, your resultant answer must be of order 3 cross 3, which has to contain 9 elements. So, how do you write product AB now? Therefore, product AB is written as 1 into minus 1, minus 1, 1 into 2, 2, 1 into 1, 1. We finished with the first row, all the columns. Moving on to the second element, minus 1 into minus 4 into minus 1, plus 4, minus 4 into 2, minus 8, minus 4 into 1, minus 4, 3 into minus 1, minus 3, 3 2s are 6, 3 1s are 3, which is of order 3 cross 3. This is about matrix AB, but we are supposed to find what? AB, the whole transpose. Therefore, what is AB whole transpose written as? Rows are changed into columns. Minus 1, 2, 1, which is in the first row becomes the first column, and it can be written as minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6 and 3. Call this as equation number 1. This is the resultant answer of the LHS. Moving on to the RHS part. What is RHS? What are we supposed to prove? RHS, B dash, A dash. We are supposed to find the product of B dash, A dash. What is B dash? What is B? Minus 1, 2, 1. The row becomes the column. So, what will be B dash? Minus 1, 2, 1. What is A dash? A is 1 minus 4, 3, which is given in the first column. A dash will become 1 minus 4, 3. What is the order of the first matrix? 3 cross 1. What is the order of the second matrix? 1 cross 3. Matrix multiplication rule states that the row of the first matrix should be equal to column of the second matrix. So how do we multiply now? Corresponding element, minus 1 into 1 will be minus 1, minus 1 into minus 4 will be plus 4, minus 1 into 3 will be minus 3. We've finished with the first element. Moving on to the second element. 2 ones are 2, 2 into minus 4, minus 8, 2 threes are 6. Similarly, the last element, 1 into 1 will be 1 itself, 1 into minus 4, minus 4, 1 into 3, 3, which is of order 3 cross 3. Call this as equation number 2. Hence, from equation 1 and equation 2, we can say that AB the whole dash is equal to B dash into A dash, because equation 1 is equal to equation 2. Moving on to the next problem, find half into A plus A dash and half into A minus A dash when A is equal to 0 AB minus A 0 C minus B minus C 0. First we are going to find A plus A dash by 2. Consider A plus A dash. What is A given? 0 A B minus A 0 C minus B minus C 0. This is matrix A. What is A dash matrix? The rows becomes the column. 0 A B minus A 0 C minus B minus C 0. So what is A plus A dash now? 0 plus 0 will sum up to 0 itself. A minus A 0, B minus B 0, minus A plus A 0 again, 0 plus 0 0, C minus C 0, minus B plus B 0, minus C plus C 0 again, 0 plus 0 will sum up to 0. A plus A dash is a null matrix, that is A plus A dash. We are supposed to find what? A plus A dash by 2, which is nothing but a 0 matrix itself. This is nothing but A plus A dash by 2. Moving on to A minus A dash. Moving on to A minus A dash. What is A minus A dash? What is matrix A? 0 AB minus A 0 C minus B minus C 0. What is A dash minus? This is matrix A. What is A dash? Rows becomes the columns. 0 AB minus A 0 C minus B minus C 0. What is subtraction of these two matrices? Corresponding element, that is A minus A dash. 0 minus 0 0. A minus of minus will become plus. So A plus A, which is equal to 2A. B minus into minus will be plus. So B plus B 2B. Similarly, minus A will be minus 2A. 0 minus 0 0. C minus of minus will become plus C. C plus C will be 2C. Minus B minus 2B. Minus C minus 2C. 0 minus 0 will be 0. This is A minus A dash, but we are supposed to find A minus A dash by 2. The next step, consider A minus A dash divided by 2. So that is nothing but 0. 2A divided by 2 will be A, B, minus A, 0, C, minus B, minus C, 0. 0 AB minus A 0 C minus B minus C 0, which is nothing but what matrix it is in the question? That is A minus A dash by 2, which is nothing but A. What is A? Which is nothing but the given question. This is all about A minus A dash by 2. We finished finding A plus A dash by 2, and then we also finished finding A minus A dash by 2. A minus A dash by 2, we arrived at 0 AB minus A 0 C minus B minus C 0. You can stop till here, or further if you want to write, this is nothing but matrix A. Moving on to the next main, express the following matrices as the sum of symmetric and skew symmetric matrices. By theorem number 2, which we solved in today's session, matrix A is equal to A plus A dash by 2 plus A minus A dash by 2. So, first problem, given 3, 5, 1, minus 1. The first step is, we will call this as matrix A. We know that what is A equal to? A plus A dash by 2 plus A minus A dash by 2. If matrix A is 3, 5, 1, minus 1, then what will be A dash? 3, 5, 1, minus 1. That is, rows are interchanged into columns. So, first we will write A plus A dash. What order of the first matrix? 2 cross 2. Order of the second matrix? 2 cross 2. Orders are same, corresponding elements can be added. So, 3 plus 3 will be 6. This is nothing but half into A plus A dash. 3 plus 3, 6. 5 plus 1 will be 6 again. 1 plus 5, 6. Minus 1 will be minus 2. This is A plus A dash. Similarly, half you can take out. What is A minus A dash? Corresponding elements has to be subtracted now. 3 minus 3, 0. 5 minus 1, 4. 1 minus 5, minus 4. Minus 1 plus into minus 1. That is minus 1. Minus of minus 1. Minus 1 plus 1 will be 0. When you divide by 2, 6 by 2, 3. 6 divided by 2, 3. That is, you are dividing each element by 2. 6 by 2, 3. Minus 2 divided by 2 will be minus 1. Plus 0 by any number, 0. 4 divided by 2, 2 again. Minus 4 by 2, minus 2. This is 0. Now, you are supposed to add this. 3 plus 0 will be 3. 3 plus 2 will be 5. 3 minus 2 will be 1. Minus 1 plus 0 will be minus 1, which is nothing but matrix A. Which is nothing but matrix A. This is all about sum of symmetric and skew symmetric matrices. Moving on to the second problem now. What is the second problem? Given 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. As I told you earlier, we will first represent this as matrix A. We know that what is matrix A? Given as A plus A dash by 2 plus A minus A dash by 2. If A is equal to 6 minus 2, 2, what will be A dash? What will be A dash? A dash can be written as 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1 and 3. Now, do we notice A dash is same as A matrix? Given matrix was A, we transposed the given matrix and we wrote matrix A dash. In this problem, we notice that A dash is equal to A. If A dash is equal to A, then what type of matrix it is called? It is nothing but a symmetric matrices. Here, A dash is equal to A. Therefore, it is a symmetric matrices. Symmetric matrices. In this problem, here A dash is equal to A, which is a symmetric matrices. Moving on to the second half, that is A minus A dash by 2. Here, 0 matrix is a skew symmetric matrices. Thus, we can write A is equal to A plus 0, which is the required expression. How to justify this statement? We are supposed to find A minus A dash. 6 minus 6 will be 0. Minus 2. you are going to find A minus A dash, minus of minus will be plus. So, minus 2 plus 2 will be 0, 2 minus 2, 0. Once again I will explain, 6 minus 6, 0, minus 2 plus 2 becomes 0, 2 minus 2, 0. With respect to all the corresponding elements of A and A dash, when we find A minus A dash, the resultant answer will be 0. Therefore, we can say 0 matrix itself is a skew symmetric matrices. Hence, A equal to A plus 0, which is the required expression. With this, we have come to an end for today's session. In case if you have any queries, please do feel free to upload your queries in the prescribed link. Thank you.